This is a factoring polynomials review. If you are factoring a polynomial that has two terms, we first ask ourselves, is it a difference of squares? The word difference means subtraction. So am I subtracting between two perfect squares? 25x squared is a perfect square, and 4 is also a perfect square. Since we are subtracting in between them, we would call this a difference of squares. A difference of squares is going to factor as two binomials multiplied together. I take the square root of 25x squared, which will be 5x, 5x. So 5x times 5x would give me 25x squared. Because this sign is negative, I need opposite signs in my binomials, and I need the square root of 4, and that's going to go in the last two places. The square root of 4 is 2 and 2. This would be the factorization for this difference of squares. I can always check my answer by multiplying, which we also call foiling. First times the first, so 5x times 5x would give me 25x squared. Outer times the outer would give me 10x. Inner term times the inner term would be a negative 10x. And last times the last, a negative 2 times a positive 2 would give me a negative 4. We notice that when we combine like terms, the two middle terms will cancel each other out, and we're left with 25x squared minus 4. If this equals what we started with, then we know that we factored correctly. If we have two terms, we could also have the possibility that we have a sum of squares. So we have two perfect squares that are being added together. In this case, we would say that this cannot be factored further. This is prime. So there is no way to factor 9x squared plus 16. If you did try, let's say you did 3x plus 4 times 3x plus 4, you would need to check this before you decided that was your answer. We're going to check by FOIL. First times the first would give me 9x squared. Outer term times outer term would give me a positive 12x. Inner term times inner term would also give me a positive 12x. Last times the last would be a positive 16. Notice that the two middle terms do not drop out. We actually end up with a positive 24x squared. Or sorry, positive 24x. So I would end up with 9x squared plus 24x plus 16. Notice that this is not what we started with. So it is not possible to factor a sum of squares. We would say that is prime. Pause the video and try to factor these two polynomials. Did you factor them correctly? If not, go back and review factoring difference of squares and factoring sum of squares. If we have three terms and we want to factor completely, then we will use what we call reverse FOIL. So we will do foiling in reverse. 6x squared minus 7x minus 20. If I would like to factor this, I'm going to start with the two binomials, and I will start with what times what would give me the first term. So I'm going to play around with factors of 6. 1 and 6, 2 and 3. I'm going to start with 2 and 3. So 2x times 3x would give me 6x squared. First times the first has to give me the first. Then I go to the last. Let's play around with factors of 20. There would be 1 and 20, 4 and 5, 2 and 10. I am not allowed to put anything with the 2 that would have a common factor with 2. So I cannot put the 2 with the 2x. So if I was trying 2 and 10, I would have a problem. That's not going to work. Let's try 4 and 5. Cannot put the 4 here because 2 and 4 would have something in common. So I will try the 5. 5 here, 4 here. Since this is a negative 20, I need opposite signs. Let's throw them in and see what happens. Minus 4 and a positive 5. We always check our work to see if we FOIL it, do we get back what we started. First times the first would give me 6x squared. Outer times the outer would give me a negative 8x. Inner times the inner would give me a positive 15x. And then last times the last would give me a negative 20. When we combine like terms, we get a positive 7x minus 20. Is that what we wanted? In the original polynomial that we were asked to factor, that was a negative 7x. If I get the right number but the wrong sign, I go back to my factorization and switch the signs. So I will have a negative 5 and then a positive 4. First times the first gives me 6x squared. Now this time outer times the outer gives me a positive 8x. The inner times the inner gives me a negative 15x. And last times the last gives me a negative 20. Now I have the correct sign on my middle term. So that tells me that 2x minus 5 times 3x plus 4 was the correct factorization. On the second problem, we have 3 terms, but the first thing that I always want to do is take out the greatest common factor. Each number is divisible by 2, so I will pull out a 2. Each term also has an x common, so I will pull out a common factor of x. I will divide out each of these terms by 2x. That leaves me with 3x squared minus 17x plus 10. Now we will continue to factor the terms left in the parentheses. Once again, we have 3 terms. I will pull down the greatest common factor, and then I will continue to factor what we have here in the parentheses. I will factor just like I did for problem number 1. First times the first has to give me the first. 3x squared, so I need 3x and x. Now I'm going to go back to the last, positive 10. My options for positive 10 would be 1 and 10 or 2 and 5. If I put the 2 here and the 5 here, let's try those two. My signs, I have a plus sign here, so the signs have to be the same. If this sign is negative, it tells me they both have to be negative. Let's check by FOIL. First times the first gives me 3x squared. Outer times the outer gives me a negative 15x. Inner times the inner gives me a negative 2x. Last times the last gives me a positive 10. So we get 3x squared minus 17x plus 10 when we combine like terms. Bring down the greatest common factor and multiply the greatest common factor in again. 3x cubed minus 34x squared plus 20x. We get the polynomial that we started with. So we know that this right here would have to be our correct factorization. Now it's time for you to try. Factor the following polynomials completely if possible. Pause the video, try the problems, and then see if you get the correct answers that I get. Make sure to check your answers. Did you get them both correct? If not, go back and review how to factor polynomials with 3 terms. Lastly, we will review how to factor if we have 4 terms in our polynomial. To factor when you have 4 terms, we use the method that we call the grouping method. The first step is to separate the first 2 terms from the last 2 terms. Take out what's common from the first 2 terms. So the greatest common factor with the first 2 terms would be x squared. That leaves me with x minus 2. Now for the second 2 terms, I will take out the common factor of 9. I will take out a negative 9, and that leaves me with x minus 2. If the binomials match, those terms that are in the parentheses, if they match, we can pull out that common binomial factor to the front and then write what we have left over in front of the parentheses. It says to factor completely. We notice that x squared minus 9 is once again something that can be factored. This is a difference of squares. So I want to factor completely. If I factor that completely, that leaves me with x minus 3 and x plus 3. Now our polynomial is factored completely. Now it's time for you to try. Here's a polynomial with 4 terms. Factor completely if possible. Pause the video and see if you get the correct answer. Did you get the correct answer when you factored completely? If not, review how to factor a polynomial with 4 terms.